Howdy everyone in YouTube land. We have a motherboard in front of us, and if you've watched my previous videos you can pretty much tell what board this is. Now this board here is not mine. It was sent in by someone who needs it repaired, and upon first inspection, oh boy, the battery is completely trashed this board. So I do not know the extent of the damage, or even if this board is salvageable. I mean, let's see if I can get some light on the situation here. It's pretty bad. And honestly, I don't know if this board is salvageable, because the damage goes pretty far back, but the majority of it's concentrated here. So, yeah, I guess we shall see. So the first things first is we got to get some good reference photos of everything, and I also need to remove that battery because it has to go completely away. Here's the back side of the board, and then expect the damage back here and see how bad it is. So we need some light. Yeah, there's some issues for sure. See some issues down here, especially over here. Oh wow, yeah, that's oof. It's been eaten. Definitely been eaten. Okay, well, let's do some more inspections. What I want to do is take good detailed photos, especially nice bird's eye shots angled down, so I can print them out and mark on them with like red marker or something, so I know which vias are open, so I can go one by one and fix it. Otherwise I'm liable to miss the vias. So, but let's get the battery off and let's clean this up with vinegar after we get the reference photos. Well, now my house smells like 1990s electronics, which is an interesting smell, especially these days. Anyways, so now that I did the vinegar trick, alcohol bathed and cleaned this board and baked it, we can kind of see the extent of the damage and what we have to do with here. So we got corrody doodle traces there that we have to go through. Perhaps more importantly, we have corroded vias here and everywhere else. And then on the top side of the board, we have lots of damage we're going to have to go with the tool. You can kind of see the rippling in the solder mask. So all that has to get scraped back, and we got to kind of see what's going on here. Lot of corroded vias. Lots of corroded vias. But the only way to really fix this properly is we need to take this 30 gauge Kynar wire and run it through the vias. Unfortunately, there's things in the way of the vias that stop you from pushing it all the way through. So we have these, which is my little pack of drill bits right here. So you can get these from Amazon, and they're very fine drill bits, especially this one here. You got to be careful and only use your fingers, because you will snap this bit otherwise. But what we want to do is we want to just run these drill bits through the holes so we can clear them out. That way we can fish wires through there and solder them on both sides to try to repair the broken vias. Because I can just about guarantee you half of these are broken. And if they're not, they will be. So this is going to be a process. So now we have to start cleaning this board up. I'm probably going to have to remove that chip so I can get an eye of everything underneath it. Surprisingly, I only found one via that's broke. And it's not even the via that's broke, it's the trace that was right next to it, which is right here. There was a break, and this was the worst affected area. That's why I was checking this the most. I cleaned up all of the vias the best I could so I can check them, and they all appear to be okay for now. So this line here was the 8042 chip select enable signal. So there's no way this chip would ever be able to communicate. You couldn't communicate with that chip, so you couldn't issue a warm reset or anything. So Yeah, now, you know what? Just for grins and giggles, why not try it? Just to see what happens. So I think we're just going to go ahead and hook it up. That would be crazy if we got that lucky. Alright, I think we're ready for power up. I've got an ATX power supply, but I'm using this adapter. And all you got to do is just ground this. So, here we go. Sounds like it's working. But it's throwing a post code immediately. 0201. Alright, let's do the feature card and see what it does. So that's, hold on. 1, 1, 1, 2, 3. 1, 1, 1, 2, 3. It's a Phoenix BIOS, that's why I'm doing that. So the way the post codes work on Phoenix BIOS is different. 1, 1, 1, 2, 3. So I got 1, 1, 1, 2, 3. So I need to find out what that is. 1 second. Alright, so 1, 1, 1, 2, 3. I went online and I kept finding 4-digit codes. Well, this is 3-digit codes. So I had to look up an older BIOS version because this is earlier than Phoenix BIOS 4. So I found an earlier version, and 1, 1, 1, 2, 3 is unable to write CMOS RAM or CMOS RAM failure. So we know the CMOS memory is in this chip. That means this guy cannot talk to this guy, so there's another break somewhere. We need to find out which one it is. So I quickly did a check. External memory, or external I/O read and external I/O write still connect through, so the problem is elsewhere. But judging how bad those pins actually are, which is hard to get on camera, I'm pretty sure there's another break. I just have to find it. Still smoking. Kinda. I had to pull the chip so I can get underneath here and check all of the traces, because there's a lot of hidden magic underneath this chip that I can't see. What I've done so far after removing the chip, I cleaned the chip up as best as I possibly could. Don't know if the chip is actually any good, who knows, but I cleaned it up, so that's done. And I also grabbed my flux remover and cleaned the board too. Now, I went through with the tool, my little grindy tool, and I went ahead and started cleaning up all of these little connections here, because the board is designed, these holes are for a socket, so you could actually, because on my other board there was a socket here, right, but this one does not have it, so you can get a socket for this and do the same thing. Now I went around and I checked all of these pads to the adjacent vias where the socket would normally go. They're all good except for this one right here, this third one down from the top. Now that one right there is actually A9. If I look at the cheat sheet that I made here, A9 is broke. So that is a problem, because that chip is missing the 9th address bit. So now what I don't know yet is if there's any breaks from these points elsewhere, but the only break from the pad to the point is right there. So somewhere, I don't know if you can see it or not, because I do not have, yeah, like right, let's do it this way. Yeah, well, you can't see it, but it's definitely broke right there. And then the 5th one down might be getting to that point too, so I need to check both of them for sure. While I have this chip off, even though we discovered that connection broken, and I went through here again and couldn't find anything, since the schematic to this board is basically unknown and it's unobtainium, what we need to do is systematically approach this. One, we know the damage is located in this section only, okay? So what we're going to do is I'm going to go from my method here. I'm going to go from bottom to top, and I'm just going to go horizontally, and I'm going to sweep all of these traces with my multimeter. So I'm going to find 2 endpoints, maximum endpoints. I'm going to check it, and I want to check every endpoint in between. If it's good, I move on, and I keep moving. And if I can't find the endpoint, like it goes over here and gets buried somewhere, I'm going to take my rotary tool, and I'm going to make an endpoint. I'm going to check it from there to the other end and make sure it's good. And I'm going to keep going through that one by one by one by one, just to make sure they're all good. And if there's any breaks, we're going to know about it. Now, granted, you can't see everything. Like up underneath these parts here, you can't see what's underneath those, and you can't see what's under these chips. So in order to do that, we'd have to pull these and look up underneath it and check all the traces underneath it and make sure they're still good. So that'll be the next approach after I do all the other traces. And then once I do the top side, I'm going to do the back side. We're going to do the same thing. And then finally, we're going to check from via to via from top to bottom. And if all of that's good, then I know we're good. So all of this stuff is checking good down here, with the exception of what I can't see under the chip. But everything, you know, that I can see is all good. I even made some marks for testing, and it's all fine. I start to run into a problem up here. There's some issues going on in here because there's a trace here. I can't figure out where it goes. It's not beeping out anywhere. And there's one here that goes up under the chip and over here somewhere, but it's not beeping out anywhere. So it's either broke or there's a hidden via. So the next course of action is to remove these chips so I can see underneath them. Now, it makes sense because this is the closest to the battery along with all this stuff. So, I mean, we've already got a break here. We already had a break up here. So this is the last course of action. So let's pull those chips. And there's some green crusties all over that stuff anyways, and it needs cleaned up, so I might as well just yank them out of there. Alright, so now that I have the chips removed, I'm going to probably put sockets back in their place because I don't know if the original chips are any good. Last thing I want to do is solder them back in just to find out they're bad, so I'm going to leave them out. But while I have this apart, I can actually start to see what the traces look like underneath, which are, some of them are quite questionable at best, but it's not really that awful. But only one way to find out. Start checking it. I pulled all of the chips and cleaned up some of these traces and verified all of this under here. It's all good. I don't see any breaks, so I put this guy back on. So at this point, I'm just gonna put the sockets back in and then test the chips with my 866. Since I didn't find anything wrong over here, as far as I can tell, I tested all the chips on the logic tester and it's all fine. So it all reads okay. So I just cleaned the corrosion off, and I think at this point what I want to do is go ahead and put this chip back on here, patch that A9, and see what happens. If it does the same thing, then the only other thing it could be is the CMOS is not getting voltage from over here, which is entirely possible. This board will work without the battery. Well, somewhat. You won't get a CMOS code anyways. So I'm thinking we got an issue with that and then that. But the beeper stopped working too. So, gremlins. I got the chip soldered back on, and I got my A9 patched. Double checked, triple checked for shorts. I don't see any. Well, now or never. See what happens. Oh, it's not even posting. Really? Wow. Okay, hold on. Let me try the CPU card. Make sure it's not that, which I doubt it is. Nope. I made the board worse. How did I do that? I'm wondering if that isn't bad. If first you don't succeed, you put another chip in it, and then we'll see what happens that time. Alright, well, new chip is installed. Now this is a 20 megahertz part. I don't know if that's going to cause any problems or not. There's the original that was all corroded up that I tried to clean up, but anyways, I still have my A9 patch here. I'm not holding out any hopes, but we'll give it a shot. Let's see. Whoa. There we go. Wow, it's throwing codes now. I've got no speaker or anything, but now at least I have codes. Yeah, there we go. No beeps or nothing, but I got a code at least. Code 00. Okay, so now we need to investigate further. Gotta love it. Alright, now that we're back from screwing around, and the original owner sent me the video card that goes to this machine, just out of curiosity, I didn't grab my VGA monitor. This is still my MDA monitor. I got the dip switches set, so in theory, this thing should work with that monitor. I hope. Yeah, there it goes. Oh, that's weird. I'm wondering if I don't have that switch right. Yeah, I don't. Oh, there it is. Check some error. Hey, the board's working. The board is working. So, see if it sees all four. It does see all four RAM. Okay, that's good. Aw, my wire came off. So it looks like it's working at least. Oh, come on. I'm gonna have to hold this on manually. I need a switch for this little harness thing that I made. It's weird how it does that though. But that just might be this particular card. Looks like it's hanging up there a little bit. Time of day clock stopped. That's a new one. So that means we have some more traces we have to find that are bad. Chances are this chip here is responsible for the clock signals. Pretty sure. So that likely the real-time clock is in this chip over here. So if that clock signal is not making it across, well, there you go. So I need to locate that and make sure that it's functioning properly. Quickly probing this circuit, and I'm going to go ahead and power it up right quick. Quickly programming this circuit, and turns out the VCC for this chip, this whole chip, there's two VCC lines here and over here, is powered from the battery circuit here, and there's a 330 ohm resistor, so that's how that works. But I'm looking at the clock signal for the real time, and it's good. It's there. That's the real time clock strobe signal. Let's just doing its thing with RAM or whatever else. So that's working. So that's high, high. Monitor this chip. Yeah, that's right. So yeah, it's good. Everything's here. So that might be normal. What I'm going to have to do is do the battery mod. Remove this resistor, put a diode in here to prevent it from charging, and I'm going to put a coin cell in there. And we'll try it out. We'll see what happens. I'm going to have to grab some of my enamel coating and just coat these traces so they don't get any worse. And then I want to put the battery in there, and yeah, we'll see if that problem goes away. That might be normal. I don't remember. I got the battery mod installed, and I want to go over this again just so people know. So there's a 330 ohm resistor that sits right here. That gets removed, and the diode goes in its place, and then this CR2032 holder gets soldered where the original battery was. So now that this is in place, there's approximately 3 volts at the 2 VCC pins, and there's 1.4 volts DC at the oscillator pins, so it's working. The oscillator's running for the real-time clock, and this chip is under power. So that error should be no more once this thing is programmed to, work properly as far as entering the codes in for the memory and all of that stuff. But before I do, I have to get, things plugged in and make sure everything works. But I think we're going to be okay now. I didn't make a lot of video of this because I didn't know which direction to take, but there is still a break in the circuit somewhere. Because if I run this thing with the 386 board, so here's an example. Let me cut the power off. I'll put the floppy controller chip back in here because I pulled it just to see if this was my problem, but it's not. So I'll put that back in, and I'll run it without the video card with the 386 chip installed, which that's normal because there's no video card. I'm going to skip the RAM test. Yeah, that's literally doesn't really do much. So if I it's just kind of like, anyways, I'm wondering, since I took the floppy controller out, it's probably throwing me an error. That CMOS, so I got to put the video card back in, so stand by. Oh, this video card, like I said, was the one that came with it. The problem with this card is, when it's not even really a problem with the card, is if I use that card, this is what happens. Yeah, it's not compatible with my little Chinese monitor, so yeah, it's a problem. But look at this. So yeah, we've got some fun going on here. I couldn't get this chip to work properly after I removed it, unless I played with it, and I see the problem right now. There's a lot of corrosion in that socket. You can see the green crusties, but perhaps worse, look at those pins. That one and that one. You see how wide they are? So yeah, I see the problem right now with the floppy drive and why it's being stupid. This socket's shot. It needs to be replaced. So that's not going to solve my instability issues with the 386 because with the video card out, it will boot on the 386 chip. Well, try to anyways. It freezes up, but it tries to. The 286 will actually boot to some degree. So, but the floppy drive, I couldn't get it on camera because all that screwed up, but you know how the floppy drive on a normal system goes during this power on self test? Well, when it was running on the 386, it went really quickly, which shouldn't do that. So it's like clocks are not switching or something. I don't know. It's weird. But I've got an itching suspicion one of these circuit tracks are open that I've not discovered yet. But considering that, and then I looked closer to this floppy drive pin, you can see it's kind of like a dark gray and crusty there. Like there's corrosion on that pin right there. You see it? It's kind of dull. So that socket's done. I got to change that before I can go any further. So let's get that out of there and replace it. I got the socket removed, and there's not really anything going on under there. Everything looks good. Did an inspection of the vias with the light and all that stuff, and I don't really see anything, so I think I'm okay there. So they're made of two 24-pin sockets, which I don't have, so I want to make something out of what I have. Now hopefully that fixes my floppy drive problem. So yeah, here we go. Oh, that's much tighter. Okay, so that's in there now. Let's grab my floppy drive. Oh, let's grab the floppy drive. And then pin 1. Let's go there. Okay, so that's handled now, I think. Yeah, anyways. Okay, power cord. Right now. See what happens. Yep. Figured that. Oh, light's not on, stuck on anymore. Beep, 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 beep. Alright, so... Hey! There it goes. Alright, so let me get a keyboard connected. Alright. Okay, do we get anything? Not really. It's trying. I need to get the monitor card and all that stuff plugged in, so stand by. Grabbed a card that will actually sync with this monitor. So, we'll get that done. There we go. And this is in 286 mode. I don't have the 386 board in there. Skip all that. Oh. Well, it's trying. It's doing that same weirdness. Yeah, it's not supposed to hunt back and forth like that. It's like it's detecting a bad sector. And then it freezes. That's what it did before. So, yeah, the socket was probably from me removing and putting the chip back in, but that's exactly what happened. So, now here's the funny part. I disconnect that. I take this this 386 card here and shove that in the hole. And turn the power on. So it's doing its thing. So if it's doing a RAM check, skip it. And then it freezes. Nothing. That's what it does. So when it's in 286 mode, the floppy drive kind of works, but it's acting strangely. It's not the drive. I've went through 4 different drives. They all do the same thing. Different cable too. Matter of fact, this cable's actually got 3. Yeah, weird. And it still does the same thing. So I'm kind of running out of ideas. There's clearly a circuit problem still somewhere. So somewhere on this board, I've either got another bad chip, like this one was bad, or one of these vias is open still that I've missed somewhere. And one of the control data address lines is missing somewhere. And that's why it's doing what it's doing. So, now, I could try the IDE, but I don't have... Maybe I do. Maybe I do. But I can try booting from the IDE drive and see what it does. And if it still gives me the same problems, I know we have an issue with the data bus. So now I got the floppy drive disconnected. It is out of the way. So I got all this kind of temporarily set up here. This hard drive is the original drive out of mine, which is the same machine, ALR. I put a different drive in it and used drive overlay software, but this is the original. So Type 17 should do this, and I think I already have it set in the BIOS anyways, but alright, so here we go. Let's see, will it work? Now, this is the 386 board. It usually freezes right here when I skip the memory test. Yeah, see, it's frozen. So no, that didn't work. Well, wait a minute. I just heard it beep. Holy shit, it's booting from the hard drive. I did not expect that. And it's not freezing. So that means the IDE bus is good, or maybe not. It did freeze. Okay, spoke too soon. Yeah, it froze. Okay, that's what I thought. But hey, I got further than I did with the floppy drive. But yeah, it froze. So, alright, let me remove the CPU card. But the fact that it started up tells me right now we've got a floppy controller problem. But I'm actually getting a lot further, so I wonder... Alright, so let's try it with the 286. Similar post time. Alright, it runs on the 286. Yeah, see. There's nothing on this drive. Just Sears crap. Now, I don't know if it's going to run or what it's going to do, but yeah, it's booting up all the way on the hard drive, so we have a floppy controller problem. But I wonder, since it did fire up on the 386, I wonder, check everything out. I wonder if when the IDE cable's not plugged in, the bus is not terminated, because this connects to the ISA bus directly. So I wonder if that's an issue. If the ISA bus is unterminated, which it shouldn't be a problem unless these terminating resistors are not, they're broken from the bus or something, which is entirely possible. Like we're missing a ground or a VCC over here. I don't know. So yeah, it's actually posting all the way though. Yeah, no, now it's freezing. It's unstable. So no, that's not what it is. All right, so we clearly still have a problem with the 386 setup. We got a problem with the floppy controller, and we have a problem with the 386. I'm wondering if they're related or not. Still got to figure it out. All right, you want to see something interesting? It's in DOS. See my frosted thingamabob here. If I freeze the RAM, the dip chips, it'll boot with the 386 board. It's running right now. As soon as I freeze that RAM, that Samsung RAM, it comes up. I tried this, I tried all of these, I tried all these other chips. Doesn't make a difference. But if I freeze these, it makes a difference. It hasn't frozen yet. That's weird. Yeah. It'll freeze when I do that. It does that in the 286 mode too. So I wonder if we have a RAM issue or a timing issue. Because when you take this, a can of air, and you say, you know, freeze spray, and you freeze it like that, it changes the timing ever so slightly. It also has thermal, it'll change thermally intermittent, you know, situations there too. So unplug the power. I bet you as soon as this warms up, if it hasn't already, I plug the power back in, let it fire back up. I bet it won't boot. I don't know. It's got to warm up a little bit. Yeah, it's starting right now. But I bet when it warms up it won't, so let's wait for it to warm up. Just for the purposes of entertainment, I'm going to pull, clean, and reseat that RAM. Because, yeah, I wonder. God, could it be that stupid? Nah, it could be that stupid. Cleaned and reseated the RAM, resocketed it. Nah. Nope, it's not that. But there is a problem in that area. I'm wondering if it's any of this dip memory. I only shot one chip so far, and it booted. Yeah, clearly we've got an issue going on with the RAM. Or we're changing the timings just enough and we're chasing a red herring. It's one or the other. What I've done now is I took 2 of the 4 sticks out and let the BIOS reconfigure itself. And we're running. Yeah, unable to air. Well, yeah, because it's, you know, it's whatever the hell that Sears software is. Anyways, so it's running on the 386 board with 2 megabytes of RAM instead of 4. Maybe that's bad. I don't know. Possible. I mean, I did shuffle up the memory sticks, so I'm chasing a problem with the RAM. That'll certainly do it. Not going to explain my floppy drive problem, but it does explain my freezing problem with that. So, starting to notice a lot of weirdness with this system. So, what I've noticed so far is I switched monitors out so I can see what's going on. So, this is running in 386 mode and it hasn't frozen yet for some weird reason. This video card is one that I picked up off of eBay because I don't have any video cards. Alright, so that's all fine and dandy, right? Now, if I take this video card out, because this one's mine, right? I set it off to the side. I take that video card out. Then I have the one that he sent me, which is original to this machine, that does both CGA and VGA and all that stuff. It's one of those multi-cards. So I put that card in. I plug that cable in, right? So we get that plugged in. We turn the power on. We fire up. We have a video signal like we're supposed to. We skip the RAM test. But look at this. Hard disk controller failure. What? How is that even a thing? Doesn't do it with that VGA card, but it does it with this one. I'm confused. But it gets better. So, obviously that card doesn't work, even though it does work, but it's stopping the hard drive from working. So we'll grab a second card he sent. There's a third card, but I can't plug it in because it's got a pin blocked off. So here's the second one. I'll plug this card in. We'll try that out. Turn it on. Look at that. What is that? So none of his cards actually work, and mine does. I'm at a loss for words. I've not seen this kind of, and yeah, it won't post either. It's just stuck there. So, I'm sucking a lot of time into this and I'm running out of ideas. So I think I'm going to end the video here. I might pick this back up once I figure something else out. But for now, that's all I got. And I'm running out of time because I got so many projects going on and I got to get ready and move to a new house. And then, yeah, it's going to get insane here in the next month. So anyways, thank you for watching. If you have a comment, and maybe you know what's going on here, please feel free to leave one. Until next time, guys.